All right, let's take a look at some of these word problems. And for this particular example, we're dealing with the number of bacteria and is increasing continuously at a rate proportional to its population. Okay, as soon as we have that kind of statement there, we're basically using this formula here, where your final amount is equal to your initial amount times e to the power of kt. All right, so these are proportional problems follow this particular formula. And it turns out that it doubles, the bacteria doubles every 4 hours, and we need to find the value of k, which is this variable right there. Okay, so before I start attacking the problem, let's just kind of figure out what's happening here. When we're at the beginning, let's just pretend we have one bacteria. So if it doubles every 4 hours, what that means is 4 hours later, we double the initial amount, which is going to be now 2, right? And then 4 hours later, that would be 8 hours in total. I would just double 2 and that would become 4. And then if I add another 4 hours, we're at 12 hours. And if I double that, that becomes 8. All right, so that's how this particular problem is kind of behaving. And what we're going to do is we're going to take this information and plug it into our formula here. Okay, so since we're going up by 4 hours each time, our t takes the value of 4. And let's just say this is our this is our initial amount, and then 4 hours later our final amount is going to be 2. Okay, so let's go ahead and plug those numbers in. So 2 equals to 1 times e, and if I take this 4 and multiply with the k, 4 times k is going to be 4k. Okay, let's just erase all that, and that's what we have in our new formula here. 2 equals to 1 times e to the power of 4k, and if you want you can divide both sides by 1. This doesn't really do anything, but we'll just do it for completeness here, and 2 divided by 1 is going to be 2 equals to e to the power of 4k. Alright, so what you want to do is you want to take this 4k, that power, and you want to bring it to the front, and the only way you can do that is by loging both sides. So along the left hand side, along the right hand side, so ln 2 equals to ln e to the power of 4k. And now we have just ln 2 on the left hand side, and on the right hand side I can soccer kick this 4k to the front, so 4k times ln of e in brackets, and this ln e is equal to 1, right? So now we just have 4k times 1, which is just 4k. So 4k on the right hand side and ln 2 on the left hand side, and then I can divide by both sides by 4. And then we'll see that the 4's cancel off, and now k equals to ln 2 divided by 4. So that is the value of k for that first problem. Okay, let's move on to the next problem. And in the next problem, I have the number of bacteria in the culture increases at a rate that's proportional to its population. Alright, so based on that statement, I can use this formula here where the final amount is equal to the initial amount times e to the power of kt. And in this problem, the number of bacteria doubles every 5 hours. How long will it take for the population to be 5 times the initial amount? Okay, so just before we start this problem, if we're looking at the beginning, for example, let's just say we have one bacteria. And it turns out that every 5 years it doubles, right? So now we go to 2 bacteria. And then if we get to perhaps 10 years, every 5 years, 2 would double into 4. And then if I add another 5 years, 4 will double to 8, right? So that's how this particular problem is behaving. Okay, so let's see if we can figure out how to kind of attack this problem by taking a look at some of the initial data here. So let me just kind of look at this part right here in the data to see if we can set up an updated formula here. So at the beginning, let's just pretend we have one bacteria times e to the power of k, and then every 5 years later it doubles, right? So that means her final amount should be double 1, right? So if we have 1, if I double that, that should be 2, right? So every 5 years later it doubles. And what we're going to do here is we're going to try to solve for this k, because we need that to update our original formula here. So I can divide both sides by 1 if you want. So divide by 1, divide by 1. This doesn't really do anything, but 2 would now equal to e to the power of, well, 5 times k is 5k. And I want to solve for this k variable, so I need to bring that to the front, and the only way to bring that to the front is by lning both sides. So ln 2 equals to ln e to the 5k, and now this 5k can just be soccer kicked to the front. So now this will be ln 2 equals to 5k times ln e. Now we know that ln e, which is this part right here, that's just equal to 1, right? So 5k times 1 is just 5k. And then I can divide both sides by 5. And now I know that k would equal to ln 2 divided by 5. Okay, so why is that helpful? Well, if I go back to my original formula now, let me just kind of erase all this. If I go back to my original formula now, my new formula now is y equals to y naught times e to the power of, well, k, we just solved for k, and k is going to be ln 2 divided by 5. So now I can replace k with ln 2 divided by 5 times t. All right, so that's my new updated formula. And now the question is basically asking, if the number of bacteria doubles every 5 hours, how long will it take for the population to be 5 times the initial amount? Okay, so if we keep on continuing here, I know the initial amount was 1, so I want to be 5 times the initial amount, right? So the final amount should be 5. And then I can just pretty much copy everything here. So e to the power of ln 2 divided by 5, and then multiply that by t. All right, so now I'm solving this particular problem here, and I can divide both sides by 1. That doesn't do anything. But what I want to do now is I want to solve for that t variable, right? So what we're going to do here is, let me just erase this so I have a little bit more space. I want to bring that t variable to the front, and the way I do that is by lning both sides. So ln of 5 would equal to ln of e to the power of ln 2 over 5 times t. Okay, and now this is all the power right here, right? This part in yellow, that's all the power. So maybe what I'll do here is maybe I'll write that a little bit. Let me just kind of write that so it's very clear here. So that was ln 2 divided by 5, and we're multiplying by the t variable, right? Okay. All right, so now that I have ln both sides, I can take this part, and that part can now be soccer kicked to the front. So this will now be ln 5 equals 2. Now I have ln 2 divided by 5 times t, and then that's being multiplied by this part right here, which is just ln e. And we know that ln e equals to 1, so I can just remove that. And after that, I can now just solve for t, and I can divide both sides by, so let me just kind of keep the same colors here. This will be ln 5, and I can divide that by pretty much this part right here, because that's just a number, right? So that's going to be ln 2 divided by 5. I'll put that in a little bracket like that. After that, you just need to go to a calculator, and if you go your calculator to 3 decimal places, you should get 11.610 hours. All right, so it takes about 11.6 hours for the initial population to be 5 times the initial amount. And that kind of makes sense, right? So if this is your initial amount right here, I mean, if you want to go to 5 times, you're roughly around there. And what we're saying is the time took about, oh, sorry, not there. If you want to be 5 times, I guess you're going to be over here, right? 5 times, and we're saying that the answer was about 11.610 hours, right? So that answer looks roughly okay, and it looks pretty good with this estimate. All right, let's move on to the last question in this homework video guide. We have another one of these word problems here, and we're asking for what is the half-life of this particular problem. So for these kind of questions, they're all following this y equals to y naught times e to the power kt. Okay, and it's estimated that 20% of a certain radioactive substance decays in 45 hours. Okay, so if 20% of the radioactive substance decays, what that means is you really have 80% left. All right, and you initially had 100%, right? So initially you had 1%, and if you lose 20%, then that means your final amount should be 80%, right? and then we times that by e to the power of k, and then ask yourself, what kind of time are we dealing with here, right? We're dealing with 45 hours, so this will be times 45. Okay, so what we're going to do for this particular problem is we're going to solve for k, and then we're going to find the half-life, which is basically the amount of time it takes to lose half of its amount, and basically we're solving for a time. Okay, so if you want, you can divide both sides by 1, so you get 0.80, and then equals to e to the power of, well, k times 45 is 45k, so I'll put that in red, 45k. All right, and then after that, you can ln both sides, so ln of 0.80 equals to ln of e to the power of 45k. And then this part right here, we can now soccer kick that to the front. So now if I keep on going, I have ln of 0.80 equals to 45k times ln e. Now remember, this ln e and that ln e, that equals to 1, right? So we can get rid of that, and I can divide both sides by 45, divide that by 45, and that is now my value of k, right? So k equals to ln 0.8 divided by 45. If I go back to update my formula now, this will be y equals to y naught times e to the power of k. Now this right here is k, right? So that's going to be ln 0.80 divided by 45, and that's being multiplied by time. All right, so there's my new updated formula right there. Now this question is asking for the half-life, right? Right? How long does it take for the bacteria to, or the radioactive substance to lose half of its value? All right, so if you're losing half of its value, initially you had 100%, and if you lose half of it, then you should be back down to 50%, right? That's half-life. And then multiply that by e to the power of ln of 0.80 divided by 45, and then times that by t. Okay, let me erase that. Okay, and our goal now is I want to find the value of the time, right? All right, so I can ln both sides. So ln on the left-hand side, then we have 0.5 equals 2, and then I can ln this side, and I have e to the power of ln of 0.80 divided by 45, and that's being multiplied by t. All right, so this part right here, now that we've ln both sides, we can soccer kick that to the front, right? So my next line, I have ln of 0.5, and that's going to equal to ln of 0.80 divided by 45 times by t, and then we have this ln e, right? And this part right here and that part right there, I mean, ln e just equals to 1, so I can just get rid of that now. And then our goal now is to solve for t, right? So the ln 0.80 divided by 45, the number in green, I mean, that is just a number here, so I can divide both sides by that. So this would be ln 0.5 all divided by this weird green expression, which is really just a number, which is ln of 0.80 divided by 45. I'll put that in brackets, and that's going to equal to your time, right? All right, so if you go to your calculator there, you should get about 139.783 hours. All right, so that's your half-life. So about every 140 hours, you're going to lose 50% of the amount, and that is called your half-life.